Let's talk about the preparation of an insoluble salt. So insoluble salts generally will appear in solid state. When we finish with our preparation process, it should appear generally as a PPT, precipitate. Now, usually if you recall in the chemistry lab, how do you actually prepare a precipitate, or how do you produce a precipitate? It's not too difficult. Usually what we do is we add one solution to another solution in a test tube, and then suddenly the entire test tube will be filled up with solids, okay? And that is the salt, the insoluble salt that you will be preparing. So that is a good method, but you do have to take note. Do you realize, number one, we have to judge and we have to recall that the salt to be prepared is insoluble. That's the first thing. Second thing, we must know which reactants that we can choose to prepare it, and both of them need to be present in this form of solutions. That means both these reactants need to be soluble. So, how do we choose the reactants? Very simple. If the salt is made from M metal cation combined with X non-metal anion, okay, MX, then your two reactants will need to be soluble salts of M and soluble salts of X, okay? So the best choice we always have is we will choose therefore M nitrates as the first reactant, because all nitrates are always soluble. That way you never make any mistakes. Then the second reactant, if I have something X that will be my second reactant, then I will have to choose, and I will probably choose a group 1 salt of the anion X. So maybe sodium something. Okay, so why do I choose sodium X? Because all group 1 salts are always soluble as well. So when you choose reactants which are always soluble no matter how, you will most probably never make the mistake of a self-limiting reagent for the preparation of an insoluble salt. So that's how you should do it. You should choose a reactant that contains the cation of your salt to be prepared and the other reactant with the anion of the salt to be prepared. So for the cation, you choose its nitrate salt, and then for the anion, you choose its group 1 salt. You put them both together, and then you produce a test tube full of precipitate, which will be the insoluble salt that you have just produced. Okay, that is very easy. Then we can extract them anytime we want. So how do we best extract an insoluble salt? Very simple. You just filter. The salt that you want can be obtained through filtration. It will be the residue after filtration has taken place. Now, of course, is that enough after you filter and you get the residue? No, because most times the question asks for clean, dry sample of the salt that you have prepared. So how do you clean this? Clean. How do we clean anything? We wash it with water. So use this term, quick wash. It's very useful for this kind of situation. So do a quick wash or quickly wash your residue with pure distilled water, all right? And then they want it dry, right? So what do? After you have washed it with distilled water, you pat them dry in between pieces of filter paper. That's how you produce a clean and dry sample of an insoluble salt that was actually collected as the residue after filtration of the reaction mixture. Right? Is this all? No. We have to now tell you why you cannot use any other preparation methods or use the wrong combination of reactants. Now, a lot of students right at the start, when you tell them about a preparation method to prepare a salt, they will immediately think of acid reactions. No, not a very good choice. Most of the acid reactions actually use acids reacting with mostly solid state reactants, okay, metals, bases, carbonates. These are all very, very insoluble, mostly insoluble kind of compounds. Not a good choice, because always remember, if you have a solid state reactant and it is interacting with the acid that's surrounding it on its outside, then the outermost surface of your solid state reactant will therefore be where the salt is formed. And you are preparing an insoluble salt. So what will you do? You will create a solid coat outside your solid reactant. That is terrible, because that solid salt that you have prepared as an external coat to your solid reactant, right? It actually blocks any further reaction between your solid reactant and the surrounding acid. How is that supposed to help you produce more salt? The moment that layer is formed, all other quantities of that same salt will no longer be possible because the two reactants are not able to come into contact with each other thanks to that solid coat that's blocking them. All right, so this is what we call limited yield or low yield. It is a proper name for the problem of this particular method. How often do you see this thing coming up? Quite often, especially for MCQ questions, they'll be asking you, why do people not choose this particular combination of compounds to prepare a particular salt? The reason, if the composition is as I said, the reason will have to be low yield. Low yield contravenes or directly is in contradiction to one of my principles of preparation of salt, which is that we must not choose a method that produces limited yield of the salt. We cannot have preparation methods that are self-limiting in production. That is the wrong choice of method. So this is a classic example of that. So never choose a combination of reactions that will give you low yield of the salt that you need to prepare. All right, so in the next video, I'll be teaching you about the kind of combination that you can use to prepare a soluble salt and some of the very important things that you need to take note of when you choose to prepare a soluble salt. Thank you very much. Click a like if you like my presentation and do subscribe to my channel. Thank you for your support.